Hi, boys and girls. It's Miss Bissell. We are getting ready to continue with our topic 7, adding and subtracting unlike fractions and mixed numbers. And you will need notebook paper for today's lesson. If you have your math book, you can open that up. We're going to be working on pages 273 to 276. You will need to go ahead and head your paper. So go ahead and pause me. Make sure you include your name and today's date on your paper. All right. You're going to need to have some good notes today. All right. So last year, you boys and girls learned about fractions that had the same denominator, and we call those fractions like fractions. So one of the things you might have had as a problem, you might have been adding 1/5 to 3/5. And what you knew from that grade is when you added your fifths together, since they're like fractions, you could add your 1/5. Sorry, got making a little noise here. To your 3/5. And since they are the same equal parts, and we know that because they have the same denominator, when you add them together, you can simply count them and see that what you have are 4/5. And then, of course, you would always look at your answer and you would see if it needed to be simplified. If you had an improper fraction, you knew that you had to divide to change it to a mixed number or a whole number. And if you had a fraction that would simplify, like 5/10 simplified to half, you would simplify that. You might have worked with a problem like 6/7 minus 1/7. And you saw when you worked with your sevens that you could just simply subtract your numerators and you would have 5/7. And then you would check to see if your answer simplified. And as you see, we worked some of them. You could work them as expressions left to right, or you can work them vertically. So they're worked a couple different ways. All right, another example might have been if you added 11/12 to, let's say, 5/12. And again, when you work with those 12ths, your answer is still going to be in 12ths. And 11 plus 5 would then be 16. And then what you know is you could divide. This is an improper fraction, so it's going to be more than 1 on the number line. 12 goes into 16 one whole time. 4 are left over, so you get 1 4/12. And then we practiced a couple chapters ago simplifying these. And I know that 4 is a factor of 12, so I know that I can simplify 1 4/12. I still have the 1 whole, but I'm renaming the 4/12 1/3. When I divide the numerators, I get 1. When I divide the denominators, I get 3. And that will not simplify. So 1 1/3. All right. And then we'll just look at one more. Let's look at a subtraction problem that you could have had last year. 7/8 minus 3/8. Again, with these like denominators, your answer is also the same denominator, and unless you simplify it, of course, and 7 minus 3 is 4. And hopefully you look at that and you see that 4 is the greatest common factor of 4 and 8, and 4/8 is the same as 1/2. So that's what you worked on last year. So that's what we're building on in 5th grade. So this year, we are going to learn how to add and subtract fractions that have different denominators, and we call those unlike fractions, okay? And there are a couple ways that we do that. We're going to learn or look at 3 different methods, all right? So the only way that we can add and subtract our fractions are if they have the same denominators. If they don't, then we can't subtract them or add them. So let's look at some of the methods. The first method is called the easiest common denominator. You'll see that abbreviated ECD, easiest common denominator. And what's so easy about the easiest common denominator is that in this method, the common denominator is always going to be the product of your two denominators. So if we have 1/3 and we're going to add it, let's say, to 2/5. All right, you see that we do not have the same denominator. They're different denominators. But what I know is when I look at my times tables, I know that 3 times 5 is 15 and 5 times 3 is 15. So I know that that these two denominators have 15 as a multiple or a product in their list. So I'm going to rewrite this. I like to stack them when I first start working with them. I'm going to stack them, and I'm going to set up right here where I'm going to take the product of 3 and 5, the product of my two denominators. Now, this is where you have to remember to use balance. So what I mean by that, the denominators drive what's going on here. So we already know 5 times 3 is going to give us 15. So whatever we do to the denominator of one fraction, we have to keep balance with the numerator. So we're going to multiply 2 also times the 3, and I get 6/15. So what I know when I keep that balance, when I multiply the numerator and denominator by the same number, I know that 2/5 is going to be equivalent or named the same amount as 6/15. All right. Now, let's look at the 3 and the 15. Remember, I said the denominator drives what you're doing. So 3 times 5 we know is 15, and 1 times 5 then would be 5. And now we have two like fractions. And when we have two like fractions, you know how to add and subtract them from your previous grade, 4th grade. You've already learned how to add and subtract those, okay? So let's look at another one, all right? So let's look at, with the easiest common denominator, let's look at like 2/4 plus 3/5. Okay, so we're using the easiest common denominator. So we're looking at 4 and 5, and a multiple of both 4 and 5 would be 20. Okay, so we're going to rewrite these fractions. 2/4 plus 3/5. We're going to set up our new equivalent fraction area. We know that we multiplied 5 times 4 to get that equivalent fraction of, that denominator, that new that new common denominator, of 20. So 3 times 4 is going to also give us a balanced like or equivalent fraction. Now, what I was getting ready to say is what we're really doing is multiplying by a form of 1. If we multiply the numerator and denominator by 4, we're really dividing it by 4/4, which we already know is a form of 1, right? We saw it up here with the 3 and the 3 and the 5 and the 5. All right, so same thing with the numerator. 4 times what gave us 20? That was 5. So we're going to multiply the numerator by 5 because we have to keep that balance. We have to keep that scale. And whatever we multiply or divide a numerator or a denominator by, we do the same for the numerator and vice versa. We saw that was simplifying. So 2 times 5 is 10. Okay. Now what you have are two like fractions that you're going to be able to add together. 10/20 plus 12/20. Okay. And we can pick up on that tomorrow. So the easiest common denominator is always going to be the product of the denominators. In other words, it's the number you get when you multiply the denominators together. That becomes your new common denominator. You write it down. All right, then you multiply, you see what you multiplied the denominator by to get the new easiest common denominator, and you do the same thing for the numerator of that fraction. Now, that one right there is the easiest, but sometimes it gets us in trouble because it leaves us with fractions that we have to simplify, either sums or differences that need a lot of simplifying. So there's two other methods that we can use too. The second method, I basically call this one, I call it the shortcut method. Now, I don't think anybody I don't think you're going to be able to Google shortcut method for finding the common denominator. But what happens here is when one of the fraction's denominators is a multiple of the other fraction's denominator. So let me look at that with this example. If we had 3/8 and 1/2, all right, so maybe we're subtracting, let's just keep adding. Maybe we're adding 1/2 to 3/8. All right, so what I notice that 8 is a multiple of 2, isn't it? So that means that I can set this up. And again, remember I said that I like to work vertically. So I'm using 8. When the larger denominator is a multiple of the smaller denominator, then we would use it. That would be the shortcut to the LCD. And L stands for least common denominator. So when I make those equivalent fractions, I come over and I know 2 times 4 gives me 8. So I have to multiply the numerator times 4. So 1 times 4 is 4. All right, and 4/8 is the same as 1/2. All right, let's work on the top fraction. 8 times 1 gives us 8. So 3 times 1 gives us 3/8. So when we add it together, we get 7/8. Okay, 7/8. All right, 7/8 will not simplify. We've talked about that. When the numerator is 1 less than the denominator, we have a relationship that's relatively prime and they will not simplify. All right, so that is the shortcut. The shortcut will help you find the least common denominator. Now there's one more method, and that is finding the least common denominator. And that one takes a little bit of work until you get really good with your times tables. And once you know your multiplication facts up and down and back and forward, this one's not so bad. So we find the least common denominator. And Miss Bissell likes this one because it keeps us from having to do so much simplifying of our answers. And for some reason, 5th graders really struggle with simplifying their answers. So this is the LCD, the least common denominator. In this method, we are finding the smallest common denominator that we can find. So to find the least common denominator, we're looking for the least common multiple of the 2 denominators in our fractions. So let's say we're going to be adding 2/3 and 1/4. So our 2 denominators are different. Actually, I'm going to change it. And let me do this as 1/8. Sorry, I'm going to change it up. All right, so this is what we do. We go over and we make a multiple list. And if you are organized with this, this is very helpful. So we have the denominator 3 and the denominator 8. All right, so 1 times itself would give you, I'll just set up another column. 1 times itself gives you 3 and 8. 2 times 3 would give us 6, and 2 times 8 would be 16. 3 times 3 is 9. 3 times 8 is 24. And I'm really working down this list until I find a match, a common multiple or a common product in my 3 tables and my 8 tables. So 4 times 3 is 12, and 4 times 8 is 32. I don't see one yet. 5 times 3 is 15. 5 times 8 is 40. All right, let's try 6. All right, 6 times 8 is 24. I'm sorry, 6 times 3 is 18. Sorry, I was jumping over. All right, sorry. And 6 times 8 is 24. All right. Usually I only have to build it out about 5, but we've gone down 6 different multiples. I see it already. The least common denominator, 6 times 8. No, I don't see it yet. Sorry. 6 times 8 is 48. One more time. maybe 2. 7 times 3 is 21. 7 times 8 is 56. All right, still don't see it. 8 times 3 is 24. I can stop right there. That's what I was looking for. My bad. That's the one that took me a little while to find. Now, this happens to be the easiest common denominator as well, but that doesn't always happen. All right, it does not always happen that way. All right, so let's do the setting up of this. So here we go. We would have 2/3, and we would be adding it to 1/8. All right, the least common denominator we just found would be 24. Making those fractions, 8 times 3 is 24. 1 times 3 is 3. So 3 24ths names the same amount. All right, 3 times 8 is 24, and 2 times 8 then would be 16. So 16 24ths. So what you see is we're multiplying each fraction by a fractional form of 1, right? Okay, now those are our new like fractions that we would then add. So let me try to think of one where the least common denominator is not the easiest common denominator. So maybe if we do 4, so let's do 1/4 plus 5/6. All right, that's easy because the easiest common denominator, a multiple or a factor of both 4 and 6 would be 24, but that is not the least common denominator. So let's set up our list for 4 and 6. All right, it's kind of like a little triple column list. So we're going to do 4, 8, 12, and I can stop right there because 6 and 12, so this would be 2 times and 3 times. So right here it is. The LCD, the least common denominator of 4 and 6 is 12, where the easiest common denominator would have been 24. So if we use 12, what's going to happen is when we get our answer, we're not going to have to simplify it. If we use 24 as the common denominator, our answer is going to have to be simplified. All right, so when we rewrite our fractions, we would have 1/4 plus 5/6, and I would use 12. That's the least common denominator. You could use 24. You're just going to have a larger fraction numbers. 6 times 2 is 12, so we multiply 5 times 2 to get 10. 4 times 3 is 12, and 1 times 3 is 3. So when we add it together, we get 13. Oh, my bad. We're not adding today. We're not adding. We're going to stop right there. All right, so we have our equivalent fractions. We see how we scaled up both the numerator and the denominator of both of the add-ins by a form of 1. We would do this whether we were adding or subtracting, okay? So we've looked at 3 different ways. We've looked at the easiest common denominator, where we multiply the 2 denominators together and use that as the common denominator, and then we set up our equivalent fractions. We use the least common denominator, where the shortcut, where we notice that the larger denominator is a multiple of the smaller denominator, and we use the larger denominator as the least common denominator. And then we looked at setting up the least common denominator by using a multiple or factor list until we found the smallest one. All right, so let's do a couple problems. So your paper is, hopefully you have all these notes. If not, rewind, pause it, and get your notes down. I'm sorry, I'm a little bit choppy. All right, and let's go in your book. This is lesson 7-2, and we're in our book on page 275. And we're going to work a couple of these problems. Stay with me until you feel like you have enough that you can do a really good job on the practice buddy. And actually, we're going to start with number 2. So number 2, we're going to find the common denominators for each fraction pair. And I'm just going to go ahead and stack them. So we have 3/8, and then I skip a line, and we have 2/3. And leave yourself some room, like a finger, to set up where you're going to write your equivalent fraction. So I'm basically going to look at these two, and we could try a couple different ways. I know that 8 is not a multiple of 3, so that shortcut method won't work. But I know that 8 times 3 is 24, so we could just use 24 as our common factor, couldn't we? And you know what? I should have thought about it, but I'm going to put a little bit of color in this. Give me just a second to grab a color. If you want to grab color, you can do that too. So I am thinking when we look over, we multiplied 3 times 8 to get 24. So 3 times 8 is how we got the denominator 24. So we're going to multiply the numerator times 8. Remember, we have to use the same number to scale up. 2 times 8 is 16. So we get 16 24s. All right, let's look at the top denominator, top add-in or fraction. 8 times 3 is 24. So we have to multiply the numerator by 3, and we get 9 24ths. So 9 24ths is equivalent or names the same amount as 3 eighths, and 16 24ths names the same amount as 2/3. And now, boys and girls, when you look at it, you see you have two like fractions, and you already know from 4th grade how we would add or subtract those. All right, let's look at number 3. Number 3, we have 1/6 and we have 1/3. So I always start with the shortcut method, and I look to see, is the larger fraction a multiple, or the larger denominator a multiple of the smaller denominator? And yes, it is. 6 is a multiple of 3. 3 times 2 is 6. So a multiple is out of the product list, right? So we just found it. All right, so let's see what we do. So we multiply 3 times 2 to get 6. So we have to multiply the numerator by 2, and we get the fraction 2/6. So 1/3 and 2/6 name the same part. And now that I have a smaller fraction, I can show you this. So I have 2/6 right here. And if we were at school, I could definitely use these with you. So we have 2/6 right here. And here we have, let me find my thirds. Here we have 1/3. Took me a minute. All right, so if you look at these beside each other, you can clearly see that they name the same amount, right? But the only way that you can make that equivalent fraction is you multiply the numerator and denominator by the same number. That basically makes a fraction that is a form of 1. So it doesn't change its value. It just changes different fractions that name the same value. All right, and you can see it right there. All right, so let's look at the numerator. The top number, the denominator. 6 times 1 gives us 6, and 1 times 1 gives us 1. So we keep that fraction the same, and then we would add or subtract. And what you have, and I meant to do that in green, what you have again, to keep that fractional form of 1, and it doesn't change the value. As a matter of fact, anything multiplied by 1 is still itself, right? All right, let's do another one. Let's look at number 4. All right, so number 4, we have 2/5 and 1/6. Your book has them written horizontally, but I like to set them up this way so I have plenty of room to set up my new equivalent fractions. Okay, so looking at those denominators, I'm looking at 5 and 6, and I know that 6 is not a multiple of 5, so that shortcut method's not going to work. And I'm just going to go with the easiest common denominator. 5 times 6 is 30. Now, if I wanted to check and make sure that that was the least common denominator, I could do this. I could do my 5 and my 6, and I could do 5, 10, 15, 20. And I could do 6, 12, 18, 24. I'm going to have to keep on going because I haven't found a common factor or common multiple yet. So then I would have what, 25, 30, and I'm going to stop right there because after 4 would be 30, and right there it is. So what I know is this would be 1 times each of those to get the multiple in the column. So I know that 6 times 5 is 30, and I know 5 times 6 is 30. That's what this helps me out with. But guys, this was actually the least common denominator. Even though we use the easiest common denominator method, this is one of those times when the easiest common denominator, luckily, is the least common denominator. All right, so let's look at making those equivalent fractions now that we can either add or subtract. So how do we get from the denominator 6 to 30? We multiply it times 5. So that means we have to multiply the numerator with that denominator by 5, and we get a new equivalent fraction of 5/30. We look at the top fraction. The denominators are what we know, and we know we multiply 5 times 6 to get to 30. So we have to multiply the numerator by 6 as well to get 12. So 12/30 names the same amount as 2/5. Those are equivalent fractions, and we are going to start tomorrow with adding and subtracting those. All right, let's look at another one. Number 5. We have 1/3 and we have 4/5. All right, so I'm looking at these and I know that 5 is not a multiple of the smaller denominator 3. I'm just going to use that easiest common denominator, and it's going to be 15 when I multiply those two denominators together. 3 times 5 is 15. 5 times 3 is 15. Now, to set up my equivalent fractions, we know 5 times 3 gave us 15, so 4 times 3 gives us 12, and 12/15 is just a different way to write 4/5. Names the same amount. 1/3. 3 times 5 is 15, so we multiply the numerator times 5, and we get 5/15. 5/15 is just another way to name 1/3. All right. If you feel like you're able to do this, you can leave. You can do the least common denominator. You can do the easiest common denominator, or you can look at that shortcut. I'm going to work a couple more. Number 6, I'm going to look at 5/8, and I'm going to look at 3/4. And this one, I know the shortcut works because 8 is a multiple, or 8 is a multiple of 4. Sorry, just about lost my train of thought. So here we go. We are going to scale up, making sure we multiply the numerator and denominator by the same number. And since the denominators of each fraction are what we already know, that's what drives what we're doing. So 4 times 2 is 8, and 3 times 2 is going to give us 6. All right, let's look at this. 8 times 1 is 8, so 5 times 1 is 5. So that fraction is going to stay the same. Anything multiplied by 1 is itself, right? So we would have 5/8 and 6/8. All right, let's look at another one. Number 7, we have 3/10, and we have 9/8. All right. So this is a case where we could use the easiest common denominator, and 8 times 10 is 80. But I'm going to show you, just because I'm really good with my times tables, because, I've been doing 5th grade a long time. Let me just show you that I also know that there's a smaller common denominator. And when I can find it, or when I think or suspect that there is one and I locate it, it's going to help me on the back end of my work because I won't have to simplify my answer. So let me look at this. We have 10 and we have 8 as our denominators. So 10, 20, 30, 40, 50. I'm going to start with the first 5 multiples. So 1 times, 2 times, 3 times, 4 times, 5 times. And then I have 8, 16, 24, 32, 40. And I'm going to stop right there because I just found the least common denominator in my list, 40. All right. 4 times 10 gives me 40, and 5 times 8 gives me 40. Okay. So remember I said we could have used 80, the easiest common denominator, when we multiplied these together, but we would have a lot larger numbers to work with, a lot larger numerators and denominators, and then our answer would have to be simplified on the back end. So just stay with me, and hopefully you'll understand why this is beneficial to use the least common denominator whenever you can. So 8 times 5, we see over here, 8 times 5 is 40. So 9 times 5 gives us 45. All right, and then we have 10 times 4 is 40, and 3 times 4 is 12. Okay, and we would add or subtract whatever that would be. I understand that this is an improper fraction, but sometimes you're going to have improper fractions when you add and subtract your fractions. All right, number 8. Number 8, we have 3/7 and 1/2. You know, I pretty much know my 7 and my 2 tables. I know that 7 can't be a multiple of 2 because it's not even. And I'm just going to go with the easiest common denominator here. And I'm going to multiply those two denominators together. And 14 would be a product or a multiple for both of those. So 2 times 7 is where we get 14. So 1 times 7 gives us 7. 7 times 2 gives us 14. 3 times 2 gives us 6. And now we have two like equivalent fractions for our original fractions. So I'm going to leave you with these 8 problems and let you start working on your practice buddy. If you did what you were supposed to, you would have some notes written down. All right, so when I worked out the problems, when I first talked about the 3 different methods that we're going to be using, you guys would have had all the notes jotted down, all right? And then you would have the first 8 problems worked out. I know it's a lot of paper, but this is a very big concept. And as soon as we understand this, it's going to make the next couple of days work very easy when we go to add and subtract the fractions. So if you need to go back and rewind and pause the video so you can get your notes, again, make sure you put your name and today's date on it, and you are going to keep your notes in your math work section of your binder. You're also going to work your practice buddy on paper with these and just have everything together, okay? So you have a couple practice buddy problems where you're going to practice finding the common denominator and writing equivalent fractions. So you've got to know 3 different ways. Easiest common denominator, where you multiply the 2 denominators together. The shortcut that helps you find the least common denominator is awesome when the larger of the denominators is a multiple of the smaller denominator. Or you can set up those multiple lists over here, and you list out the multiples of your 2 denominators until you find one that is in both lists. And then that would be your least common denominator. So 3 methods for you to work with on finding common denominators. All right. I hope you have a good day. And if you need me, note my office hours. I will have those posted on the stream page of the Google Classroom. They will be a little bit different for each homeroom class this week just because of where we are with our schedules. All right. Have a great day.